So I was assigned in a certain problem with application of the integral we've learned from ES 81. So let me read this to you. A diffusion model involves two identical compartments, each of volume V, which share a common boundary surface of area A. The boundary between the two compartments is permeable membrane, but the rest of the surface of each solution or compartment is impervious to diffusion. Initially, the compartments are filled with solutions of certain solute of different concentrations. Let X sub O and X denote respectively the initial and instantaneous concentration of the solute in the more dilute solution, and let YO and Y denote the initial and instantaneous concentration in the more concentrated solution. So, in solving this problem, we have the given condition X plus Y equals XO plus YO, and following the fixed law of the fixed law is applied commonly in problems including solution, dilution of it, and taking the amount of solute or solution in a compartment. So since we have two compartments, we'll first get the amount of solute in the first compartment with respect to time t. So dx over dt equals KAV and XO plus YO minus 2x. So how are we gonna solve this one? This problem, we're gonna be this is a long solution, so bear with me. I hope you get it. We're gonna combine like terms because this is a separable equation. So we have dx over XO plus YO minus 2x is equal to KA over V dt. Right? So we need to integrate both sides, and that will give us first we let U is equal to XO plus YO minus 2x. So remember, our initial concentration XO and YO are constant, so don't confuse it to be X. Okay, so deriving it with respect to each variable, we have du is equal to, so this will become 0. Derivative of constant is 0, so minus 2 dx. So negative 1/2 du is equal to our dx. Okay, so going back to the equation, we'll have negative 1/2 integral of du over u is equal to k at over v plus c. And now to integrate the left side, we'll have ln of u to the negative 1/2 is equal to this one. This, as we remember, c could also be ln c, and we join those ln's, transfer it over here, so I will get ln u to the negative 1/2 over c, and it is equal now to e k a t over v. I'm sorry, so we have not yet raised it to e. So raising it both sides to e, and that would give us u to the negative 1/2 over c is equal to e to k a t over v. And now remember this one, so we'll simplify it. We'll make it u to the negative 1/2 is equal to c e k a t over v, and To make u simpler, you need to multiply it by negative to the power of negative 2. That would give us u is equal to c e to the negative 2 k a t over v. Since c to the negative 2 is just c. And you're returning the equation for u. We have this one. Remember what we've let? So xo plus y sub o minus 2x is equal to c e to the negative 2k a t over v. So remember, we are finding here what's in the compartment x. So we must leave x on the left side, making negative 2x equals negative xo minus yo plus c e to the negative 2k a t over v, and multiplying it by negative 1/2. Then that would make x of y is equal to xo plus yo minus c e to the negative 2k a t over v all over 2. Right? So remember, it said in using a t is equal to 0, our instantaneous x is equal to xo. And with that, we'll make it x of 0. So this is x of t. I forgot. I get used to solving differential equations without application. So x of 0 is equal to x sub o plus y sub o minus c e to the 2 times 0 and blah blah blah. So this will become 1 over 2 is equal to x sub o, and that will give us xo plus y sub o is equal to 2x sub o and plus c, and that will give c is equal to y sub o minus xo. Now since we have our c, then we can go back to the equation x of t, replacing c, our c, with the value we get here, and that would give us, so where should I write my final answer for it? Here? Yeah, here. Sorry. So x of t is equal to x sub o plus y sub o minus y sub o minus x sub o times t to the negative 2k a t over v all over 2. So here's my final answer for the compartment x. So we have an overview of the solution. Okay, here's it. Yes. So you can pause it again, and remember that this time we're only solving for compartment x, and the problem asks for the 2 compartments. So the next thing we're gonna solve is at compartment y at any time t.